All right, Python students, today we're going to talk a little bit about the workings of a network. We're going to learn about how to get information across a network, and we're going to learn quite a few new terms in this lesson, but they're necessary in order to move forward as we talk about how to make our code interact with network APIs. So, the first term that we want to talk about is HTTP. And you've probably seen this in your browser in your URL when you type a web address. It's like http www.gmail.com. HTTP stands for Hypertext Transfer Protocol, and it's a set of rules for sending and receiving information over a computer network. When computers talk to each other, especially if they're far away from each other, like your computer from, let's say, maybe the Hotmail server in California, they need a set of rules in order to communicate effectively. Think about sending a package to someone on the other side of the country. We have certain rules for mailing a package, like it has to be wrapped in a certain kind of box. It has to have the sender's address and the recipient's address, and the address has to be in a special little format. Those rules are necessary, and that's what the P in HTTP stands for, is the protocol. So that's just a set of rules on how those networks talk to each other. And that brings us to our next term, which is a server. The server is a program that resides on a computer, but a program that provides access to information over a computer's network. When computers communicate, it's usually because one computer has some information that the other computer wants to know. The computer that has the information in this case is called the server because it serves the information to other machines. A server usually specializes in some particular type of information. For example, for map information, or the box office totals for different movies, or maybe it's your email server and it specializes in providing that access. Servers can be small as even on an Arduino or a Raspberry Pi, or they can be a single personal computer on your desktop. Some people have their own server set up at home, or it can be giant servers that require entire rooms of data. Think about companies like Amazon or Google and the information that would be housed there. So the server that or the computer that gives the information is called the server, but the computer that asks for the information is called the client. A client is a program that gets information from a server and uses it to complete a task. The program that wants to know that information is the client, and in our lesson, the programs we are writing will always be the clients. We will always be the ones getting information from that server. So this is a visualization. Imagine that the models and between the computers, they have relationships. And in this example, there's one server with information and multiple clients that can contact that server at the same time. The server and the clients can be located anywhere around the world, and they can communicate over the internet. Some of the benefits of having this type of structure might be that anybody can access it. Each of the client computers access the same version of information. So I don't have to change information on every single client. I change it on my server, and then those clients ask the question. Some drawbacks of that information: if I have a link that fails, it is potential that my clients might lose access to the data that I want, or it might just be too busy. So there's some redundancies built into the system to help prevent some of those issues, but occasionally we still have issues where servers go down, and that causes, we've seen some of that this year with our Gmail and some of our school Google Docs and everything else. And those servers crash. Sometimes we have some issues that go on. So let's explore a sample program that uses HTTP to get some information from a server. So if you'll switch over to your code window, and then go ahead and open up your project, open up part 2 localpets.py. Okay, in part 2 localpets.py, I want you to go ahead and open and run part 2 local, and I'm going to give you about 1 minute to explore this program. So push pause on your recording and take a minute or two and just explore and see what this program does. All right, welcome back. So this program, as you probably figured out, it prints out information about pets in your state. Now I want you to push pause again, and I want you to take another 2 minutes to experiment. I want you to try changing your code. Find some places in your code and change it, and see what happens. All right, welcome back again. I hope you had a little fun experimenting with your code. If you just continued on without pushing pause, shame on you. I know who you are. I can see you. Just kidding. I can't see you. But I really do hope you did take a minute or two to experiment with that. The data model that's being retrieved in this program, what is it? We have this server equals api.techsmart.codes. We have a thing called a path. We have this URL. We have response. And our main data type is called all shelters. All shelters equals response.json. And what that's going to contain is a list of all of the shelter dictionaries that has a list of pets that can be adopted. So we reach out to a website and we ask them for information. So they have a limited amount of bandwidth and things that they can send us. So a lot of times they'll package that up into a nice little package. And here we're going to see some JSON packages. And then they send that out. And through that API for JSON, we know how that's formatted and we know how to use it. So when we printed all shelters, we got that dictionary of pets. So there's some libraries that are new to us here. So the library that we're importing is called the request library, and then we have this other new library called PP. Okay, the request library and the PP library are a little bit new, and we're going to continue to look at how those new libraries work in a little more detail. All right, so let's switch back to our notes. When a client, that's our program, wants information, the first thing it has to do is send a request. To make a request, the client code asks the server to do something, and it gives it any information that it needs to know. Then the server will give us back some information, which we can then store in a variable. This looks similar to making a function call. So in our code, we might say, so we've imported the request library, and inside the request library, there's a .get method. So take a minute and write those down. Push pause, write them down, and then continue. When the client makes the request, the server gives us back a response. Usually this is the information that the client requested, assuming that nothing went wrong. So pause this show, write down the definition of response, and write down the syntax in blue. Notice that when we do request.get, we have to use the assignment operator to store it. All right, passing information back and forth between the client and the server is called the request-response cycle. The client program makes a request. The server then responds or acknowledges the request. The client decides what to do with that data. If it needs to, the client can make additional requests for more information, and the cycle will continue until the client has everything it needs, and then it will disconnect from the server. Since the server's far away and this sort of communication takes time, because of this, making requests and waiting for response can often take a few seconds. So as you're writing your code and you're writing our sample programs, don't panic if that program creates just a little bit of lag. Give it a little bit of time and then move on. Now, in order for the client and the server to understand each other properly, both the request and the response must be in a specific format. Think about a conversation between you and a friend. If you're speaking English and your friend only speaks Spanish, then you may have some difficulty in communication. You're both saying exactly what you need to say, but neither one of you can understand each other. So when we're making a request to a server, the client will need to give it several pieces of information. The most important is the URL, which says where to look for the information in the first place. We'll learn more about that in just a minute. The next two parts we won't be working with as much. Headers are special information about the request being made and the type of information in the response. Headers a lot of times are like the address label on an envelope. Okay. While headers are important, they always start with default values that will meet most of our needs. So we'll almost never change them inside of our Python programs here. The body of the request is the information the client wants the server to add to its collection of data. However, this is optional and we won't be using any request bodies in this lesson. So the word URL stands for Uniform Resource Location. It is the complete address of the information on a computer network. So it's not just like www.gmail.com. It has to include the http:// because sometimes there you'll see that those are HTTPS, and sometimes there's something called an FTP, which is a file text protocol. So it's not always just www in the address. The most important part of the request is the URL, and it tells which server we want to talk to and where the information lives on that server. So pause and make sure you've written this down in your definitions. You're probably familiar with URLs. Your browser uses them for every website it visits. Whenever you type a URL into the address bar at the top of the browser, it loads a page. You're actually making a request. The URL is the place on the internet where you want to go. You want information from that web server. So you put in the URL, you hit enter. So such as https://platform.techsmart.codes. Your browser is then sending a request to that URL and you get to our website. So if we break apart the URL, it can be broken into several parts. The first part is the protocol that we're using. So in this class, we'll always be using HTTP or HTTPS, which are the protocols of the modern internet. The S is just an extra layer of security that adds some data encryption. The next part is the domain. The domain says which server we're going to visit. In this case, it's the TechSmart platform server. So the domain is what we're most commonly familiar with. It's the gmail.com or the hotmail.com or the twitter.com. Those are the parts of the address we're most familiar with. After the domain, sometimes we'll have more information that is called the path. After the domain comes the path, which starts with the /. The path tells us where on the server the information is located. Think of it like going a big giant server in a big office building. By default, you end up in the lobby. But sometimes we want to go to the 4th floor and visit room number C131. So the path might be the floor number and the room number. Okay. So let's try making a request to the server. We make requests using the Python library called requests. To make a request, we get a function called request.get. After a few seconds, the server should give us a response which we can store in a variable. So let's switch over to our code and follow along. All right, let's open our project one more time, and this time let's click on Part 3 Job Board. Inside of our Part 3 jobboard.py file, we are going to make a request. To start, we'll need the URL that we want to access. The assignment panel gives documentation about how to get the information we want from the server. So as we read through our assignment panel, we'll see that our job search API demo contains information on tech jobs, and our base URL is api.techsmart.codes/. We have JSON job search, and it gets tech jobs. The path is /jobs, and the response example. So this is that API I was talking about. We have to know it's going to give us back a data set, and we need to know what that model looks like. So in this example, it's going to give us a list of dictionaries. Inside that dictionary, we're going to have 1, 2, 3, 4, 5 entries. And it gives us what the key is for each entry. We get a title, a salary, an employer, a role, and some requirements. Using that API, that gives us enough information that we could break this apart and use it for all kinds of things. But for now, we're just going to practice a little bit on how to get and store and print that response. So let's take a look at our base URL variable in the code. So instead of typing this long address in every time, we're going to go ahead and store it as a base URL. And notice we've already imported our requests. Okay, so the base URL variable includes the HTTP, which is our protocol, as well as our domain, api.techsmart.codes. Based on what we see in the documentation, the base URL is missing something. It's missing the path to either employers or jobs. So let's come in here and let's add some information to our code. So we're going to put some more lines in here. Let's add a new variable called URL. Okay, so we're going to extend the URL. We're going to have our base URL plus and then we're going to use our slash job search slash jobs. So again, that's coming straight from our assignment window when we got our instructions. So we got our HTTP API TechSmart slash, so job search slash jobs is coming right there from that assignment window. Okay. So we're going to concatenate that to the end of the URL, and then we're going to go ahead and create the variable where we're going to store our response. So we're going to say response equals requests.get, and then inside that .get, we have to give it our URL. Okay. And then let's go ahead and print our response. So remember, it's going to take just a minute. And again, request is not defined. Oops, what did I forget? Oh, I forgot my S. See? All right, try again. So I get response, bracket 200. Is this what we expected? Probably not. We probably expected a list of jobs. But the thing being printed is the whole response. There's one more step we need in order to break that out. So let's switch back to our notes. We're going to come back to this and we're going to break that apart, don't worry. But let's switch back to our notes and go a little bit further. Okay. So what the server gives us back has a very specific format, just like our request had to have a specific format. The first part is the status code, which we'll learn more about later. All you need to know for now is that what you want to see is the number 200. The number 200 is our code that means everything worked as expected and we got information back from the server. Like the request, the response has some headers, but like the request, these values we're mostly going to ignore because we don't need to deal with them. What we care about is the status code, that it was successful, and the body, which is going to contain our message. So that JSON stands for JavaScript Object Notation. It is a common data format used to exchange information over a computer network. So the response.json. Servers we work with will always give us back this JSON package. And it looks very similar to the format that we've already seen, being that list of dictionaries. You might see some minor differences, such as the use of the word null instead of the use of the word none, or using some lowercase letters for Boolean variables. But since we're not writing our own JSON, we don't even really have to worry about that. JSON is technically one long string in the body of the response. To turn it into Python nested collections, we call the .json method on the server's response. And that calling of the .json method will give us our nested collection. It breaks that string apart into the type of data that our Python programs can read. So let's switch back to our code and try to decode that message. So let's switch back to our coding window. Our package, our project should already be up, and we can continue on. So we're going to remove the print response. We tried that once. It gave us a status message of 200, and now we're going to break it apart. So we're going to say the body of our message is equal to response.json. And now let's try to print body. Now, instead of response 200, we see this list. We see the list of dictionary, and we see these key value pairs. And that's what we want. Okay, so that's an ugly print, and we would probably want to use some for loops to pretty it up. But there's also a little bit of built-in. There's a pretty print, or PP function. It's a special function that's used to print out nested collections, not just the ones from our response, but from any others as well. And it's built into Python, but it requires an import. So let's come back up to the top of our code and import that library. So unlike most functions that we import, we don't even need to put a library name first. You can now just use the PP function anytime you would like to otherwise use the print. So instead of print body, let's change that to the function name. So let's do the pretty print of the body. So it takes a little bit more time because it's got to do the formatting, but it automatically adds the nesting levels, and it puts each dictionary entry on its own line. So that's a little bit easier for us to read. The body is nested and on its own lines. We can comment out that PP and replace it. So let's go ahead and comment that out, and then come in here and say for job in body if job bracket employer equals Google print job. Let's see what job offers Google came back with. Very nice. And again, instead of the print, now we can substitute that with the pretty print. So we've taken that dictionary and we've searched for an employer that's Google. We found one job for Google, and it gives us all that information. All right. So in this lesson, we learned about how client programs send requests to servers. We learned what data is required to send a request, and we learned that the response can be stored in a variable, and it has a specific type of format. We learned how to use the JSON package to interpret the results of our request, and then we learned how to use the pretty print method. Coming up, we'll take a few more looks a little bit deeper into these APIs, and we'll make requests to some publicly available servers outside the TechSmart Pro platform, and we'll send some additional information with our requests. For now, I want you to go ahead and practice your 2 assignments that are in your agenda for today.